project which is used to quickly find information via a search query of relevant books. So the whole idea is to get a list of relevant books based on a search query. So our project was built off of this project Gutenberg. That's actually an open source project that we found. And Project Gutenberg is a Django project. So Django is just this nice web framework that allows you to quickly build websites. And Gutenberg is actually a project for just accessing catalog information on Project Gutenberg. So it didn't relate to the actual text. It stored metadata like the author and the title of the book. So we built off of that, and we added the text of each Gutenberg book, and we also added models into the database to store things like tokens and the postings, which keep track of the term frequency for a given token in our book. And we also did some caching to keep track of similarities between books, because we also created a kind of a simple item-based recommender. So first I'm going to give you a demo of the Gutenberg Retriever itself, and then I'm going to walk through some of the code just to give you an understanding of how it works. So if you're following along and you follow the instructions in the README file, I don't know where that README file is, but if you follow the instructions in the README file, this one, you can get actually a server up and running. So I'm just going to, well, I don't know why, but my computer's a little funny. These are some issues that I had earlier. But we have on the left, we have the Postgres database, which is running. And so here I'm activating the virtual environment. I called my virtual environment Guten. This is the Gutenberg environment. And you can get your server running if you're in the Gutenberg project directory. You can get your server running by typing python manage.py run server. Now you also have to run the management commands, and they go over that. That's done in the README file, so you want to make sure to read through that. But you have to run the management commands to get all the information in your database and all that stuff, so this works. If things don't work, it's because you don't have the right information in your database. So I'm going to run the server, and it's going to do its stuff. So this is just a really simple local server. You wouldn't do this in production because it can only handle a handful of requests. But the first URL we're going to do is this query URL. And so the website, you can type in a query, and you can select a distance metric, and you can also select a vector transformation. So I like this query because it's pretty obvious that it's our searcher is working. And we'll start with cosine distance, and we'll use the TF-IDF transformation. So we see that it's actually doesn't take too long, which is nice. You'll notice that if you enter in a ton of search terms, it takes longer. And for books, when we get over to book similarity, it takes a really long time. But we enter an email and we see great. We have Zen and the Art of Internet. That makes a lot of sense. There's the jargon file. I don't know what that is. Surfing the internet. These are all clearly things that are related to email. So great, we have some relevant documents, and if you want, you can even click on it, and voila, you have the documents. So that's pretty cool. We have like a pretty nice way of being able to search for books by search term. And I actually haven't tried this. I know that we have the Jungle Book in here. I think one of the characters, Mowgli. I guess that's not. So if you search for something that doesn't exist at all, it's not going to return anything. I'm trying to think of characters in the Jungle Book. Yeah, maybe not. I want to say Jungle Book. Jungle and Book. I want to say, maybe I'm dooming myself here. You should never do live demos of things that you haven't really actually looked into yet. Well, guess we can't find Jungle Book in here, but it was worth a shot. And the terms are sometimes kind of funny. One of the things you'll notice, I think Jacquard distance. I found cosine actually sometimes wasn't giving exactly what we wanted, but you can do different kinds. I think something weird that we'll see with like book searching is that there is oftentimes this, there's strange header text that comes over, so it does have a negative effect on the on the ability to search. But in the end, it's clear that it does work. The email example is a good one just because email is um, a very, I guess, unique word. It's pretty obvious when you type in email that it does work. Jungle and book, on the other hand, we only have 100. Right now, we only have 100 books in our that we pulled over. The more books you have, the longer it takes to run all the management commands. 100 was a decent number. Let's see, we got the Wizard of Oz in there, so we could do like Lion, Witch, Dorothy, and see what happens there. Maybe we'll get the Wizard of Oz. Wizard of Oz. Yeah, no dice. I'm really gonna take it with a grain of sand because things are kind of crazy. But anyway, so that's the document searcher, which is pretty cool. Now we're going to do the book recommender. So that's another URL. It's books recommend, and so here we see a list of all of the books in our data set. So these are these are all the books in our data set. So let's do, I guess, like Tale of Two Cities. Again, this we have 5 distance metrics. So we found that Pearson took like way too long computing the sparse vector, because Pearson requires that you compute the sparse vector, I think. At least that's what we were. So with Pearson, it takes a really long time to do that. So all of these are actually computed offline. So we have the book similarities stored in our database, which means that all of them will, the search actually goes pretty fast. And there you see it. And I see these CIA World Factbooks coming up a lot in the top, and I think it's because, I'm not even sure why. It's hard to say. But in the end, it does behave as expected. I'm trying to think. Again, the one I really like to use is that email book, email 101. If we search, and I also found that cosine distance wasn't really the best. But we see, surfing the internet up there. Oddly though, yeah, cosine distance we had some trouble with, but other ones like, I guess, Jacquard, I thought had a little bit better. Zen in the Art of the Internet, Surfing the Internet, yada, yada, yada. So I don't know. I'm not sure why cosine distance came up so poorly. In the end, I mean, in the code, all these calculations are pretty straightforward. So it's not like there's some weird logic error. And strangely, actually, in our evaluation, cosine ended up doing the best. So, but anyway, yeah, this is our website. It would be cool if you could actually rank. You could provide feedback for these. So Django's nice in that you can add users and stuff like that. So it actually would be possible to rate these books, and we could provide some kind of collaborative filtering on the user level. So that's the search algorithm. I'm going to walk you through now the back end and the project itself. So the project is all hosted in this Gutenberg thing. This requirements file is all these different requirements specific to the project. You're also going to have to install Anaconda. There's a link on the website or in the README file, but you have to install Anaconda, you have to install Postgres, and you have to get Postgres running. To get Postgres running, I don't think they mention it, but yeah, it's literally just this Postgres D command. This is all in Mac, so I don't know. I hope you have good luck doing it. And unfortunately, we weren't able to host this on a production server, so you won't be able to access it via some website. You'll have to get it running yourself. But anyway, this is the Gutenberg project directory. We have books, which is the application. The two important ones are books, which is the application, and Gutenberg, which is the which is like where the configuration files are hosted, along with some like template stuff and whatnot. But really, the big one is books. And within books, we have this evaluation directory, which is solely for storing evaluation information. Management, which is where all of the commands for, all those management commands that you run in the setup Python. So, the management commands are Python they're Python manage.py, and then you type in a management command. You have to run it from this directory. And this will give us a list of all the management commands. But the big ones are the ones in books. So you'll find these under management commands in books. And the big ones that we wrote were evaluation, parse, recommend, and, well, actually these five. The only one we didn't write was update catalog, which is what pulls all of the catalog information or the metadata about the books from Project Gutenberg. So again, if you go to books, models, here's all the information about the books themselves. So these models were mostly created, again, as part of the Gutenberg project. They keep track of the meta information about each book, the author, the authors, and the download count, and so on and so forth. But the ones that we added are text is parsed, tokens, and the distance. Text is just the book text that you saw. Is parsed just keeps track of, if we were to add more books into our database, we want to know, like, have we parsed them for the tokens or not yet, because we don't want to be parsing books like more than one time, because that'll mess with the token count. The tokens this is a many-to-many model because we have this master list of all the tokens that appear throughout, all the unique tokens that appear in all the books in our data set, and we use this posting model to keep track of the relation between each individual token and each individual book. And we also have this many-to-many self-referential distance metrics, which keeps track of the distance between each book and every other book in the data set. And the nice thing about this is it lets us compute the book distance ahead of time, because that is actually it takes a pretty long time to calculate the distance between each book, especially depending on what data set and what transformation you use. If you use the term frequency inverse document frequency transformation, this distance calculation can take a pretty long time if you're calculating the distance between the book the user is searching for and all the other books in your data set. So then we have all these helper functions, creating the sparse document, or term frequency inverse document frequency vector. But the really important ones here are cosine distance, Jacquard distance, and dice, because these are the metrics that we get to use. So within these, you can actually pass it a transformation, and we created a nice utility function in utils for the transformation. So I believe it's just transform. So we ask it to get the transform vector, and we have TF-IDF binary and no transformation. And then here are the actual transformations that occur. But anyway, so we have cosine distance. In the end, we get the transformation, and we pass it to this cosine function. And this cosine function is it's just imported from SciPy, and this is the distance function. So it's not the similarity, it's the distance. And so yeah, in the end, we know that's why I take it with a grain of salt that those results are a little wonky, because we're using this nice SciPy library. We actually implemented our own as well. If you want to look at utils, you can look at our own implementation. That's where these magnitude and sum of squares and dot product helper methods, that's what they're all for. because we initially did just implement cosine distance ourselves, but then we decided to use a third-party library because it was much faster. But yeah, that's cosine, Jacquard, and dice. And then here's the posting model. So each posting has a book and a token, and they're unique together. So each book, doesn't have the same token attached to it multiple times because it should only have one. And then each posting keeps track of the term frequency, and that's the frequency of that specific token in that specific book. But then we also have the token model, which keeps track of each token. And in the token model, we track the document frequency, the total number of occurrences in all data sets, and the name of the token itself. And there's this nice helper for calculating the inverse document frequency. And yeah, that's the token model. And then finally, we have the distance and distance type model. And these are for keeping track of the the cached distance calculations. So the distance function has 2 books, and we calculate the distance between them in that management command. And then once we've calculated the distance between them, we store it in this distance metric. And we have a distance type, which is it has a foreign key to the distance type table, and these are all the distance types that we have. Cosine, Jacquard, dice, and Pearson and Euclidean. Again, Pearson and Euclidean we found took a little bit longer, so we implemented those only in the cache version. But we do cosine, Jacquard, and dice we make those available on the query side. Also notable, if you were paying attention, on the book record, on the recommender, we don't offer a transformation. We just always use TF-IDF because we found that to be the most effective. I didn't want to store all of those. It takes a really long time to compute all of the relations to all the books. So even with 100 books, calculating in addition all of the distances to also compute the distances for all of the different transformations, it would have taken too long. So yeah. But that's the whole thing, really. Again, I guess I can go to the books and the management and the commands. Actually, the evaluation is important too. So if you wish to run evaluation, you'd have to go to the you want to have your evaluation database and your book database separate. Because the way it runs these calculations, it's not aware of the fact that you would have 2 databases. Unless, I guess, if you like the evaluation, you don't want to have it. The evaluation data set itself doesn't know about these books, so you have to keep them separate. And to do that, I do describe it in the README file, but I'm just gonna. There's this m variable, and you can use these. Here's my secret key. Fortunately, I'm only hosting this project locally, so it doesn't matter that I show that. And here's my database name and password. But if you want to run the evaluation data set, you're going to want to create a Postgres database called eval, and you're going to want to change the database name to Gutenberg eval, so that it doesn't clash with the evaluation. But yeah, that really is it. I could walk through the management commands, but you can read those yourself. Well, to hell with it. I'll walk through those too. You can stop the video here if you don't want to see the management commands. But while we're here, you might as well give as full of a demo as possible. So the management commands are in books, management, commands, and we'll start with, so the first one is update books. And I'm glad I did this because, the first one's actually update catalog, but that's a third-party library. Somebody else did that. I'm not going to demo that. It just goes on to the Gutenberg website and it downloads this catalog information, and then it stores it in a relational model. It is a lot of grunt work, and I'm really thankful that was there to begin with, because it allows us to make a lot more features available to the user if we so choose. But the big thing here in update books is this book count variable. We set it to 100 because if we were to download all of the books on Project Gutenberg, it would have taken an insurmountable amount of time to calculate all the distance. Our website would have been slow. Again, we're working on a small scale here, so we just kept it to 100 books. That was enough to get an idea of the proof of concept. So all of these methods here were heavily influenced by this nice library here that helps you, once you have an endpoint, it handles going on to the Gutenberg website and downloading the text, and this all takes care of formatting the strings that you're using to send this GET request off to their URL, and that's all stuff that I don't want to mess up. But yeah, fetch text, format, it's all just about going onto the Gutenberg website and grabbing the text information. And so again, all of these I borrowed from the Gutenberg website, and there's a little bit of code here for stripping the headers. So that's important stuff, because you see it in a lot of those books. Strip headers wasn't as effective as I hoped that it would be, because there's still some garbage, but there's a lot more garbage in each of those files that you pull over if you don't strip that first. But the important part of this command is that we're looping through all the books in our database. We're only using books with English. Gutenberg ID, this one is just an ID that doesn't exist, and we're making sure that we're getting text, because there's a whole ton of other stuff on Project Gutenberg, a whole bunch of other formats that we don't want to worry about. But we're going and we're getting all these books on Project Gutenberg, and we're only getting the number of that we specify in book count, and then we're storing it on this book object's text parameter in our database. So that's the update books command. I'm just gonna so that once you've retrieved the books, you can do this parse function, and this uses this nice thing in our utils, get word count and create postings. But it just goes through all the documents that haven't been parsed that have text, and it goes ahead and it gets the word count, which is this heavily borrows from NLTK. We're using these stop words that NLTK makes available. The Porter stemmer from NLTK. I think punctuation's something in Python's built-in library. So, but we're using other libraries to do the stemming, to remove the garbage punctuation, and then we convert the token to lowercase, and we get rid of stop words, and we make sure that it's words and not a number. And then we add it to this giant stem words list, and then we use this Python counter thing, which takes a list of just tokens. So now we have all of the words, we've converted all of them to tokens, we've removed the garbage, we have this giant list of tokens, and this returns a hash table where the key is the token and the value is the number of times that the token that token appears in that list that you passed into counter. And so once we have that list, we then can create the postings. So we have this is the number of times that these tokens appeared in this list, and we're going to pass the book itself, and we're going to pass the counter, and we're going to go through all these, the token really, and the count that occurs in this counter, and we're going to either create the token or we're going to get it if it already exists. and then we're going to increment the total number of occurrences that token has occurred by the count for that book that we passed. We're going to increment the document frequency by 1, and we're going to save it. And then we're going to create this postings object, which ties the book to the token, and it keeps track of the number of times that that specific token occurred in the book. So that's the entire parse function. We then set the book to parse, and then we save it. So again, that's the parse function. And the last one is the recommend. There are also 2 separate eval functions. Those are pretty much the same as the book function, except for they're for evaluate. Actually, the second one of the evaluation functions is the exact same as what the parser is doing, except for the time data set. And then the second command is actually for like running the evaluation, getting the predictions that our program would have predicted for each of those, returning that ranked document list so that we can do the precision recall curve. But anyway, here's recommend. This is for our book recommender. This is what takes care of getting all of the distances between all of the books and caching it. So yeah, I mean, this is pretty straightforward. It goes through all the books. It gets the TF-IDF for each book. Because we're only doing TF-IDF. So now we have all of these sparse TF-IDF vectors, and then we're computing the Pearson distance, the Euclidean distance, the cosine distance, the Jacquard distance, the dice distance, and then we store them in our model. And each of these is for storing the Euclidean distance in the model, and we have to do it twice because we have to relate book 1 to book 2, and we have to relate book 2 to book 1 to make sure that the relationship's symmetrical. And again, we do it for all the different distances, and then we just print the book so that we know it's working. But yeah, that there is that's everything. Thanks for watching. Hope you enjoyed this as much as I did.